Okay, we're going to talk about the electrochemical cells, which most people would call batteries. So that's like a chemical reaction which you use to generate an electric current or a voltage, and how that relates to the reactivity of metals. Okay, so you probably recognize this column here as a partial reactivity series. So starting off with sodium, very reactive, and going down to silver, which is the least reactive. So I'm going to put there increasing reactivity. Now, what do metals do when they react? They lose electrons. And when they lose electrons, they're going to form positive ions. That's kind of a chemistry definition of a metallic element, one that can form a positive ion when it reacts. Okay, so that means then sodium is the best at losing electrons. And Ag down at the bottom there is silver. That's the worst one at losing electrons. That's got the lowest tendency to give away electrons. Right, now let's look at this table in red here, which shows the metal ions. So this is the metals in their compounds. So whenever sodium's in a compound, it's always like a Na+, like an NaCl. Whereas the blue one, this is the elements. Now we think Na metal is the best at losing electrons. Once it's lost electrons, it's got a noble gas electronic configuration. And once it's Na+, it's got very little tendency at all to accept electrons. Really bad at accepting electrons. Whereas silver, that Ag+ down at the bottom, because silver metal is not very good at losing electrons, that means that Ag+ is actually reasonably good at accepting electrons. So I'm going to write down that way, okay? Best at accepting electrons. Okay, now what we've got to the right hand side here is a very simple electrochemical cell. Let me make it a little bit bigger. So what we have got here, this here is copper metal. This can be any one metal. I'm saying this one is copper metal, Cu, and here we've got a different metal. We've got zinc. Now if you connect and you put those in what's called an electrolyte, which just means it means an ionic solution with some ions dissolved in it. So e.g. you could have sodium chloride solution, that would work fine there. So if you put two different metals in an electrolyte and you look at the voltage, you'll get a reading, you'll get a voltage, okay, on the voltmeter there. And let's see what's happening there then. Well, what we've got is we have got copper here. Now, any metal, is the pure metal, but it will also have a little bit of oxide on the surface of it. It always will have some compound. Now, copper oxide has got Cu2+ ions in it. And of course, it's got O2- ions, so I'm not worried about them. Right, and here we've got zinc. Now, what did I say? We said that copper 2+ is actually fairly happy to accept electrons, right? Whereas zinc is a reasonably reactive metal, so that's good at giving away electrons. And that's exactly what happens. So the zinc will give electrons, and the electrons will travel through the wire, through the voltmeter, and that's you, okay? And electrons will go to the copper 2+ ions there, and they'll join on with the copper 2+ ions. They'll actually turn them back into copper metal. That's what's going to happen. And here what's happening, the zinc is giving away electrons, so that's going from Zn to Zn2+, and 2 electrons, and the electrons go around the circuit. Right, now if you try and use that to light up a light bulb, it doesn't really work, okay? You can measure a voltage, okay? And you could just about get it to light up an LED, which doesn't use much power. Okay. Now, if you looked at the reading on the voltmeter there, you would actually find out that in this case, when you use copper and zinc, the reading on the voltmeter, the volts, is equal to 1.0 0.10 volts, okay? And also, because the zinc electrode is the one which is giving out electrons, that's going to be the negative electrode, and the copper is going to be taking in electrons, so that's going to be that's going to be positive potential, because that's drawing electrons towards it. Now, you can imagine if we replace the copper with an even less reactive, so let's get rid of that copper and we put silver in there. What do we say about silver? We said silver, I should do it in blue really, because that's the metal. Okay. Oh no, I have Ag plus, sorry, yeah, in red. That is even better accepting electrons than Cu2 plus. So that means there's, that draws electrons towards it too. So the voltage, you'd find out, would be a little bit bigger than that. It would be higher than 1.1 volt. Now, you'll see a lot of questions where you get to compare lots of different metals here. So what I've got here is I've put, I've actually got lead, okay, there. So this is Pb. And what we've got, so that's lead metal, and this is going to be metal 2, the second metal. And we're going to measure the voltage on this voltmeter. Now, when you collect it with magnesium, you get a very big voltage. You get the biggest voltage on this chart, 2.24, because magnesium is actually a very reactive metal. So it's very good at giving away electrons. And you'd find out that it's got a negative sign there. And that negative means that the magnesium is giving away the electrons. So in this case, the magnesium is the negative electrode, and the lead, Pb, is the positive electrode, because that's taking the electrons in. We see, swap the magnesium for a piece of aluminium, stick with the lead as the first metal. You don't get quite such a big voltage, only 1.53 volts that time. That's because aluminium is not quite as reactive, and as you go down the table, it gets less and less, as we see, until if you connect it to lead itself, then obviously you're going to get 0 there, because you've got the two metals are identical. They've got the same tendency to give away and accept electrons, so you won't get a voltage. When you connect up to copper, then you notice you do get a voltage, but the voltage is in the opposite direction. Now the lead, which had been the positive electrode, the lead will become the negative electrode. And that is because lead is better at giving away electrons than copper is, because it's more reactive than copper. So you can use this way of connecting the metals up to work out which metal to compare the reactivities of metals. And also, I've compared them to lead. You could compare them to any other metal that you wanted. Okay, so let's see, for example, say if we had got rid of the lead there. So I'm going to cross that out, and I'm going to put in, let's say we've got Fe in there, and cobalt as the second metal. Now we'd be able to see there, if you did that, look, that's the difference you'd get is be minus 0.31 minus 0.15. So you'd get, so the voltage there would be equal to minus 0.31 minus 0.15, and that gives you plus 1.6. Sorry, minus 0.16. Why are you going to get that? Right. Why are you going to get minus 0.16 volts? All right, that's the difference in the voltage between the iron and the cobalt. And which one is going to be the negative electrode? Well, hopefully you'll be able to see that it would be the iron. This would be the negative electrode, because that's better at giving away electrons. And cobalt is not quite as good as giving away electrons, so the cobalt there would be forced to accept the electrons. So the cobalt would be the positive electrode. So iron would be the negative, and cobalt would be the positive electrode. And you could compare any pair of those metals. I've just chose iron and cobalt. You could have any two you like. You could use cobalt and nickel. You'd only get a tiny voltage there, because if you look at that, you'd only get a voltage of minus 0.03 volts. And which one would be the most negative one there? Well, it would be cobalt, So cobalt would be the negative electrode, and the nickel there would be the positive electrode. Okay, you want to get the biggest possible voltage. Well, if you could compare magnesium, the most negative one, with silver, the most positive one, and then you're going to get a voltage of, what? Let's see what it would be. It would be minus 2.24 for the magnesium, minus plus 0.93 for the silver. That would be equal to 3.1 minus 3.17 volts, and the minus sign shows us that the magnesium is the negative and the silver would be the positive electrode. Okay,